Welcome to this explainer. Look, if you're gearing up to tackle some home wiring, you are in exactly the right place. I'm putting on my hard hat today and stepping into the boots of a rigorous professional safety inspector. And my one absolute goal, keeping you alive, intact, and totally accident-free on your DIY projects. Because let's face it, electricity, well, it doesn't care about your good intentions, and it definitely doesn't hand out second chances. That's why we're going to walk through the official safety blueprint drawn straight from the core standards of electrical work. We are treating your home project with the exact same level of scrutiny as a massive commercial job site.
Okay, let's dive into this. Here is the official 6-step audit checklist that literally every pro uses. We're looking at the golden rule, killing the power completely, gearing up for the job, securing your work environment, code compliance and capacity, and finally, knowing when to stop. All right, starting us off with Section 1, the inspector's golden rule. This is the absolute law of electrical work. Let me be crystal clear right out of the gate. Compliance here, it's not optional. This is the absolute bedrock of all safety. I want you to burn this into your memory. Test before touching. Seriously, committing to this one single action prevents the vast majority of severe electrical accidents. It is your ultimate safety net. You know, on my job sites, we never, ever assume a circuit is dead until we've physically proven it. You might think, oh, I flipped the right switch, but listen, labels in older homes are notoriously wrong, wiring gets crossed by previous owners like a giant puzzle, and assumptions get people hurt. Always verify that equipment is fully de-energized with a proper tool before your hands get anywhere near those conductors or terminals. Moving right along to Section 2, killing the power completely. Disconnect, lock, and verify. So, the crucial point is how you actually execute a safe job flow. It's this undeniable 1-2-3 punch of an elimination protocol. Step 1, switch off that circuit breaker. Step 2, and this is where so many amateurs fail, guys, use lockout or tagout methods. And step 3, the final verification, use a multimeter to confirm absolutely zero voltage is present. Let's zoom in on that second step for a second, because lockout tagout, it isn't just bureaucratic paperwork. It's a literal physical barrier. It's a safety procedure designed to make absolutely sure dangerous machines are properly shut off and literally cannot be started up again while you're doing maintenance work. In a home DIY setting, this physically stops your spouse or maybe your roommate from wandering down into the basement, seeing a flipped breaker, and just casually turning the lights back on while you're upstairs holding a bare copper wire. If you can't lock it out, you tape it off and you tag it clearly. No exceptions. Okay, Section 3, gearing up for the job. We're talking professional PPE and tools. I can spot a professional from a hobbyist before they even touch a single wire just by looking at their gear. If I walk onto a site and this stuff isn't there, I shut the job down. Here is your non-negotiable loadout. Insulated gloves, safety glasses, because arc flashes are absolutely no joke. Non-conductive footwear. Your screwdrivers and pliers, they must be properly insulated tools designed specifically for electrical work. Cheap plastic handles from the dollar store just won't cut it. And finally, properly rated and calibrated test instruments. Guys, you are trusting your actual life to that little screen, so make sure it's good. And hey, while we're on the subject of your physical state and gear, I really need to hammer home this absolute environmental restriction. Never work with wet hands or in damp conditions. Water is highly conductive. Mixing water and electricity, it's a notoriously fatal combination. If you're sweating heavily or, say, standing on a damp basement floor, you stop the job immediately, period. All right, Section 4, securing your work environment. Let's talk about hazard recognition and elimination. Safety doesn't just happen inside the junction box, right? It extends to the entire physical space around you. And this brilliantly illustrates the difference. On one side, an inspector-approved workspace, clean, dry, and totally clear of debris so you can step back safely if you need to. On the other side, a hazardous workspace that is just begging for a catastrophic accident. Damp floors, clutter you can trip over, flammable materials sitting right near a potential spark. Look around before you start and get those flammable materials far away from your work area. Once your space is perfectly clear, you need to play detective. You've got to actively inspect the cables and equipment you're about to touch. Here's your hardware checklist. Actively hunt for damaged insulation on the wires. Look for loose connections. Those are prime culprits for arcing. And definitely watch out for any signs of overheating, like scorch marks or melted plastic. If you spot any of these defective components, don't ignore them, don't just slap electrical tape over them, you replace them immediately.
Next up, Section 5, Code Compliance and Capacity, Standards, Loads, and Grounding. All right, this is where I put on my super strict code enforcer hat. Electricity operates on unbreakable rules of physics, and our safety standards? They're basically the mathematics that keep those physics safely contained inside your walls. You must always comply with the National Fire Protection Association, the NFPA, their NEC standards, as well as your local municipal regulations using approved materials. Listen to me on this one. Electrical codes might seem incredibly tedious, but I promise you, they exist because they're written in blood. Literally every rule in that book is there because a terrible accident happened in the past. Follow the local rules.
Now, what's really interesting about this is understanding the why behind the rules. A circuit rating isn't a mere suggestion. It's the absolute maximum electrical load a circuit can safely handle. You have to match it perfectly with the correct wire size and protective devices. Respecting this math is exactly how you avoid overloading the system. And avoiding overloads means you prevent thermal breakdown, you prevent melted wires, and you prevent devastating house fires. And a massive part of that code compliance is maintaining proper grounding. You've got to verify that your equipment and outlets are properly grounded. And honestly, here is my sternest warning of the entire day. Never remove grounding conductors. Never ever cut off the grounding pin on a plug just to make it fit into some old two-prong outlet. Bypassing these grounding mechanisms removes the literal safety net that was specifically designed to dump rogue electricity harmlessly into the earth instead of, directly into your heart. Let's move to and see how this builds into our final section, Section 6, knowing when to stop, recognizing your limits. The tools are great, the code is fantastic, but you know what? The absolute most critical safety device you have on any job is your own judgment. So I'm posing this question directly to you right now. When is a job just too complex for a DIYer? It's time to set the ego completely aside for a minute. Because not every job can be figured out with a quick internet search. You need to hit the brakes and consult a professional, licensed electrician for certain things. I'm talking about getting into main distribution panels, dealing with high-voltage systems, or tackling major wiring modifications to your home. And honestly, the golden rule of limits is this. If you are unsure about any procedure at any point, you stop and seek professional guidance. Calling a licensed pro for this complex stuff isn't a failure of your DIY skills. It's the smartest, most mature safety decision you could possibly make. Which brings us right back full circle to wrap up this explainer. I want to leave you with this one provocative thought to ensure your next DIY project is a totally safe one. The next time you are standing in front of an open